Namaskar, hello and welcome to NCERT's live phone-in program. My name is Tanvi Khurana and in this chemistry class, if you are a science lover and you like particularly chemistry, then you must watch this session. In this chemistry class, we are going to talk about, learn and understand surface chemistry. What is it all about? Are there any practicals that you are going to watch? Well, there's a lot in store for all of you. So watch this session and try and learn with us. If you have any questions regarding this topic and you have some queries you want to ask our expert, then please write your questions and send it to us on our email ID dth.class12@ciet.nic.in. You're watching us on VmVideocon Channel number 12. All the 12th class students, this session is for you. This chemistry session where you can ask your questions, your queries, and we would love to solve all those queries. And if you're watching us on our YouTube channel, which is NCERT official, write down your questions, queries in the live chat box and we'll receive them instantly, and our expert, she'll try to answer all of them within this session. Let's meet her. We have with us Mrs. Swastika Sharma. Welcome, ma'am.
Hello, ma'am.
Ma'am is a PGT from DAV Public School, Vasant Kunj, New Delhi. So let's begin with the basic definition of surface chemistry. Ma'am, what exactly is surface chemistry? Could you please explain it to our viewers?
Welcome, viewers. Surface chemistry deals with the phenomena related to chemistry which are happening only on the surface of the any species, whether it is solid, liquid or gas. So all the phenomena happening on the surface comes under surface chemistry. We are going to deal with it in detail.
Okay, so shall we begin and talk about something else regarding the surface chemistry?
Yes, dear learners, let's observe our surroundings. So if you see, if I talk about this pen, this is made up of plastic. You know, plastic is a colloidal solution. If I talk about the ink filled in this, that is also a colloidal solution. And even if I say the houses you live in, they are also colloidal solution. You know, the school you go, the school building, this NCERT building, this all is made up of colloidal solution. And children, when you go to school in the morning, you love to have milk. So, you know, milk is also a colloidal solution. You love to eat bread, butter, jam and even butter, cheese. These all are colloidal solution.
Right.
When I was coming to NCERT, on the way there was lot of pollution on the road. There are so many vehicles there. So you know that all pollutants together, when they get mixed into air, that also makes colloidal solution. And Tanvi, if I ask you, when you get up in the morning, first thing you read in the morning, what is that?
I read the newspaper.
Yeah, even I read the newspaper. Today in the newspaper I read that school are opening for the students of senior classes and there will be offline exams.
Yeah.
So students, newspaper is again a kind of colloidal solution.
Okay.
So we all are surrounded with colloidal solution, you know. So they are so important in our life, you know, whether we talk about the meals, the things we eat or the clothes we wear or maybe the wooden furniture we have, or even if we talk about the houses, newspaper, and it is there in our kitchen also. So you know, these all things, they make our surrounding, they all are colloidal solutions, they are colloids.
Okay.
So you know, how will you distinguish whether a particular given thing is colloid or it is something else? You have studied in class 10th that there are three kinds of solution: true solution, colloidal and suspension. They can be segregated on the basis of particle size. If the particle size is between 1 to 1000 nanometer, it comes under colloidal dimension. If the size of the particle is less than 1 nanometer, it is true solution. If it is greater than 1000 nanometer, it is actually a suspension. So this all you have studied in class 10th, but today we'll talk about the colloidal solution. So if I say, as we have talked about the size, how will you define colloidal solution? Colloidal solutions are actually heterogeneous mixtures. And they are generally, I mean, most of the colloidal solutions are made up of two substances. One is dispersion phase and other is dispersion medium. You know, dispersion phase is the substance which is dispersed in the medium. It is generally present in small amount, but the other one which is present in the main component, that is dispersion medium. So we have dispersion medium which is present in major amount, other is dispersion phase which is present in small amount. So when a substance is dispersed in another substance, that is called as a colloidal solution. We have different type of colloidal solution. You know, one of the colloidal solution is we have classified different categories of colloidal solutions are there. As you can see on the screen, one is when solid is dispersed in solid, they are called as solid sols. There is one more category, second last, if you see, when gas is dispersed in solid, that is also solid sol. So we can say that if dispersion medium is solid, then it comes under solid sol. You might have seen in the jewelry which your mother is wearing, that is colored glasses, you might have seen colored gemstones are there, topaz is there, and they all are coming under solid sols. Most of the time children think that these are actually solutions. When I talk about colloidal solution, they are not always in the form of colloidal solution. Sometimes they are in the form of solids also, liquids also, and gases also. If I talk about the second category, when solid is dispersed in liquid, it is commonly called as sol. So the paints which you are using at home, cellular fluids which are present in our body, they all are called as sol. You know, the spelling of sol you must consider, it is SOL, it is not SOUL, and it is not even SOLE. So you must take care, when solid is dispersed in liquid, it is called as sol and its spelling is SOL. If you move on to the another one, solid is dispersed in gas. When dispersion medium is gas, they are called as aerosols, because air is there, gaseous substance is there which is there in the dispersion medium. So smoke, dust, as I was talking about on the road, there was lot of smoke, dust, particles are there, so they are making aerosol. This is also a kind of colloidal solution. You know, you eat cheese, jellies, that is there. So gels, they are called as gels. I'll give you a very popular example of gel. You use hair gel, children. You must be knowing hair gel is actually liquid dispersed in solid. Solid is in more amount and liquid is in small amount. There is another category of colloidal solution. When liquid is dispersed in liquid, both of them are liquid, it is called as emulsions, and examples you all are familiar with. This is milk, butter, hair, creams, these all come under it. Aerosols I have just discussed, and solid sols also has been discussed. So let's talk about foam. What is foam? आपने अपने घर में सोफे की गद्दियाँ देखी होंगी, cushions देखे होंगे. So you must be knowing that liquid is present in the as the main substance and gas is dispersed in it. So it is actually foam. Foam can also be considered as froth. This is actually झाग जो हमारे बनते हैं जब हम soap solution बनाते हैं, leather बनाते हैं, उसमें mainly it is liquid and gas is dispersed into it. So children, these all are the categories and they all are not solutions. Actually they are present in all three states: solid, liquid and gas.
Okay, ma'am, the chair we are sitting in, this is foam, so is it the same that
yeah,
we are talking about?
Tanvi mentioned it very rightly. The furniture, wooden furniture, the foam on which we are sitting, this all is actually made up of colloidal solution. So we all are learning together, this nice experience. So as
one more thing,
yeah,
so because we are talking about colloids and you were mentioning about the sols, different sols, and there's one more sol which is associated with milk. What is that? Lithophilic.
Okay, are you talking about, she is talking about lyophilic, I think.
Lyophilic.
Okay, right. So I would like to mention that souls are of many types. I am coming to that only. So dear learners, अब हम move करेंगे the phenomena which are related to our life and which is associated with colloids only, and there are certain phenomena called coagulation. I am coming to that. बेटा जब घर में अब summers आ रही हैं, if milk is left outside, it is not kept in the fridge, you must be knowing that a soaring of milk happens, जिसको हम बोलते हैं दूध का फटना. You know what is it? In chemistry, it is called as precipitation of milk or coagulation of milk. So Tanvi, it generally happens in the houses in the summers.
It does. कभी-कभी हो जाता है. तो we can see मम्मी उसका पनीर बना देती हैं.
Yes, very good application. So colloids, once they get coagulated, once they get precipitated, then they can be used as paneer also, as it happened in the case of soaring of milk when coagulation happens. तो बेटा आप जब next time घर में पनीर जब दूध फटेगा तो आप मम्मा को क्या बोलोगे? You will say
this is
coagulated. This has been coagulated. Okay. So now you are learning with your common life experiences. So as ma'am has asked, Tanvi ma'am asked me, what is lyophilic? So milk is an example of lyophilic soul. Now you would like to ask me, what is this lyophilic? Actually, all colloids are classified into two categories. One is lyophilic and other is lyophobic. Name itself indicate, philic means when there is affinity. किसके बीच में affinity? Between the two components of colloidal solution, that is dispersion phase and dispersion medium. So when there is affinity between dispersion phase and dispersion medium, we call it as lyophilic soul. As milk is one of them, it is quite stable. You have seen under certain condition this get coagulated, but generally speaking it remains stable. Another category of colloidal solution is lyophobic soul. Phobic means when there is no affinity, there is some hatred, or you can say when there is very little affinity or no affinity between colloid dispersion medium and dispersion phase, then we say it is lyophobic souls. You know, lyophobic souls are not stable. Not very stable as lyophilic are. They need to be stabilized with certain things. They get very unstable readily, even if you add very minute quantities of an electrolyte or something. So I'll say lyophobic souls are not very stable. They readily undergo precipitation or coagulation. Beta, coagulation and precipitation are exactly same. So how will you define coagulation? So as Tanvi mentioned, we can say that coagulation means aggregation of colloidal particle and they settle at the bottom. So settlement of the colloidal particles at the bottom, and this kind of phenomena is also called as precipitation. So moving ahead, if I talk about different, generally milk get coagulated easily at room temperature in summers when the temperature is slightly high, but other colloidal solutions, they do not get precipitated easily. You need to get them coagulate under certain conditions. So there are different techniques of coagulation. I would like to mention what are those techniques of coagulation. Let us see first technique, which is called as electrophoresis. I'll show you an activity. Dekho, this is a W tube. See, this is a W tube.
Yes, ma'am, our students can see that you are holding a W tube.
Yeah, so this is W tube. This is easily available in your lab. If you make a colloidal solution of ferric hydroxide, it can be filled into this. This is ferric hydroxide, and you know this is filled into this W tube, and then
Okay, it's now.
It is half filled. You can say you can fill some amount of ferric hydroxide again into this, and you will see now we have enough quantity of ferric hydroxide.
Yes.
These are 2 copper wires. Ideally speaking, we need to take platinum wire or maybe some other electrodes of graphite because they are inert in nature. But because copper wires are easily available in the lab, so I have tried with this and I got very good results. So I will tell you how easily we can perform this activity, and I have performed and I will show you the result of it also because that apparatus is already set. Tanvi, please help me. Thank you so much. You can see this W tube, I have already filled it with ferric hydroxide sole, and then I have inserted the 2 electrodes in the form of copper wire here. You see both of them are inserted into this, and then some amount of electric current is passed through. Don't connect the wires directly with the main current because that will be dangerous for you. So you see I have connected it via battery eliminator. This is the battery eliminator which is there, and you know when keep it aside for maybe for 1 hour or 2 hours, and then you will see that you can see initially this is a kind of solution which you see, this is ferric hydroxide solution, and after passing current for some time, maybe around for 12 volt, if you pass it for 1 hour or 2 hours, then you will see these particles, colloidal particles, get shifted towards one of the terminal. Here there is only dispersion medium, and this side there is dispersion, these colloidal particles are getting collected here. So this kind of phenomena of migration of colloidal particle is called electrophoresis. This is one of the technique of coagulation or precipitation. The particles are getting connected to one of the terminal. So what is electrophoresis? Electrophoresis is the migration of colloidal particles towards one of the terminal when colloidal particles, when electricity is passed through colloidal particles.
So ma'am, here you have used copper. If you have used something else, then the results would have been the same?
Generally results remains the same. Only thing we have to take those kind of electrolytes which are non-reacting with the chemical which is already filled in this.
Okay.
So this kind of phenomena, what do you think, Tanvi, can it be performed with milk also?
I hope so.
Yeah, Tanvi is very right. I'm sure that you are also getting it. All colloidal solution, whether it is milk, blood or ink, they all can, if you pass electricity through them, they'll be attracted towards one of the terminal, and coagulation will happen. So this is one of the technique of coagulation.
Okay.
So
Shall we keep it there?
Yeah, we can keep it here. We need to keep them safely. These are chemicals. Then children, in this process, if you see electrophoresis, what is the theory behind electrophoresis? If you see here, the particles which are attracted, that is towards the that electrode which is connected to the negative terminal. Why is it so? So if you see, I hope you know that ferric hydroxide is a positively charged colloidal solution. So if there is positive charge, as you can see here in the screen also, that ferric hydroxide, which is ferric oxide hydrated, this is also ferric hydroxide. Basic dyes are there. Hemoglobin is also one of the kind of charged particles are there. So these all are there, and you will see in this ferric hydroxide is positively charged colloidal solution. It will be attracted towards the oppositely charged terminal, that is about the negative terminal. Same thing will happen with the negatively charged colloidal solution. If you take any sole of copper, silver, gold or sulfide soles, and if you pass electricity through them, you will see that they will be attracted towards the positive terminal of the electrolyte, which is connected to the positive terminal of the battery. So shall I say, in electrophoresis, It is the migration of colloidal particles towards the oppositely charged terminal, and this process causes what? Coagulation or precipitation. So, you know, this is one of the technique of coagulation.
So here, ma'am, you have mentioned the things which will go with negative, which are negatively charged salts and the positively charged salts.
Yeah.
They are very different.
Yeah, so all lyophobic salts are actually either positively charged or negatively charged.
Okay.
You know, so if it is positively charged, they will be attracted towards the negative terminal, and if the colloidal particles are negatively charged, they will be attracted towards positive terminal, means towards the opposite terminal.
Okay.
And this is electrophoresis. Yes, Tanvi.
Ma'am, there's one question. One of our viewers, I think he or she joined late, and he's asking, what is soul? So just a simple definition for the viewer.
Soul is also a kind of colloidal solution in which solid particles are dispersed in liquid solution. So shall I say, when ink is a drop of ink is filled in water, you will say that this is a colloidal solution, soul. So solid particles dispersed in liquid, that will be a kind of soul. And I can give you some examples, like if you say, just now we discussed, it is about soul is actually there are certain paints, certain cellular fluids are there. So I want to say there are two substances. One is dispersion medium. Dispersion medium is like a solvent which is present in more amount. Dispersion phase in a small amount, which is like a solute. So when solvent is liquid and solute is solid, then we say it is a kind of soul, solid dispersed in liquid. So that is called as, is it? I hope that your query is solved. So
I'm sure he must have understood your answer, he or she. All right. So let's go further, and I can see that you have a lot of things to explain to our viewers.
Yes, there is second technique of coagulation, which is about mixing of two oppositely charged sols. You know, I have taken here ferric hydroxide sol, which is surrounded by, which is absorbed by positively charged colloidal particle, which is ferric ions are there. You know, if there is a layer of positively charged particles around a colloidal particle, it becomes a positively charged colloidal solution. And as you can see, arsenic sulfide, it is surrounded by sulfide ions, it becomes a negatively charged colloidal solution. And you know, it is very essential for the colloidal solutions to absorb these kind of charges, otherwise they won't be stabilized. Let me explain this first. So whenever you have a colloidal solution, it is stabilized by absorbing a layer of ions, because if there is a layer of ions around it, then it will not be mixed up with the other ions of the same type. And when they are not getting mixed together, they will remain repelled, they will remain in the isolated form, and it will remain in the colloidal form. But somehow, if all the colloidal particles join together, as it happens in electrophoresis, then it get coagulated or precipitated. So here, as we initially also mentioned, that there are two types of colloidal solution, positively and negatively charged. So you can see here, ferric hydroxide preferentially absorbs ferric ions around it. So it is a positively charged colloidal solution. Arsenic sulfide is making a layer of sulfide ions which are absorbed around it. So it is a negatively charged colloidal solution. So when such two solutions, such two colloidal solutions are mixed in definite proportion, in a fixed proportion, then you see ferric ions will be neutralized by sulfide ion. और अगर neutralization हो जाएगा, फिर क्या होगा बेटा? Then these charges will disappear, then all the molecules of the two sols, they will join together, and when they join together, they aggregate, they become heavy, and they settle down at the bottom in the form of precipitate. So this is also a technique of coagulation. I would like to mention again that if these charged particles are present around the colloidal particle, it gives stability. But somehow if these charged particles are neutralized or reduced, then coagulation will happen, because then it allows the particles to come closer and turns into the form of precipitate. So here also the same thing happen. When the two oppositely charged colloidal particles are mixed, they actually neutralize the charges, they get aggregated and they settles at the bottom. So this is another technique of you can say coagulation or precipitation.
Okay, and we just received a question.
Yeah.
And it says, colloidals, are they stable or not? And you have just answered the same.
Yeah. So children, again I would like to say, if you talk about lyophilic, they are quite stable, but they can also be coagulated. Lyophobic, they don't have affinity, so they are not very stable, but they can be easily coagulated. So here I have shown the reason for stability, that is the adsorbed layer. The adsorbed layer is responsible for causing the stability of a colloidal solution. But if two oppositely charged colloidal solutions are mixed in some proportion, fixed proportion, then these charges are neutralized and then they get coagulated. I hope your question is answered.
Yes, I hope Aditya you have got your answer. Ma'am just explained the whole process, and let's go further and ask ma'am some more questions.
Yeah,
so
I would love to answer the questions. Tanvi, shall we move to the other techniques of coagulation? Second technique of coagulation, it can be done by boiling also.
Okay.
You know, I'll take maybe one of them, like if I talk about ferric hydroxide only. This is my ferric hydroxide, and as I have told you earlier, this is a positively charged colloidal solution. These are ferric ions which are adsorbed. Preferentially they absorb common ion around it. You know, so ferric ions are adsorbed around it and it is quite stable. This is another particle of colloid. This is also ferric hydroxide. We have taken a single solution, and this is again positively charged particles are adsorbed around it. You know, when you boil ferric hydroxide solution, you know, this ferric hydroxide solution after boiling will lose the adsorbed layer around it. So this adsorbed layer will disappear. Why? Boiling में kinetic energy मिलेगी. These bonds will break down between the adsorbed layer and the colloidal particle, and when this adsorbed layer will disappear, again they will club together, they will join, they will aggregate, because there are no charges, and when there are no charges, they all will coagulate and settle at the bottom. Again coagulation will happen. So this is another technique when we are learning coagulation by boiling. So these all phenomena are happening in the kitchen, in everyday life. When you are making food, you are boiling certain things, and colloidal solutions are getting precipitated. Sometimes they are getting converted to different states. So we are always dealing with colloidal solutions. We are dealing with the phenomena related to colloidal solution. So I hope you have understood by boiling how do you do the coagulation.
yes.
We have another methods of a few more methods of coagulation.
Okay.
Yeah, so I am moving on to the next method of coagulation, and that is, you see, it is called as dialysis. It is very interesting to see this activity. Again I am going to perform this activity. Let us see. Here we have a paper. This is called as butter paper. This activity can be performed with parchment paper or cellophane paper. You know, but I have taken butter paper. It is available easily in the local market. It was there in my lab, so I have taken this butter paper. So what do? You make a pouch of it. I'll reduce its size, and you know, now it is of small size, and you can make a pouch of it. एक छोटा सा आप इसका ऐसे करके बैग बना लो. ठीक है, हमने इसका एक ऐसे करके बैग बना लिया, और इसके अंदर हम एक funnel भी introduce कर देंगे, ठीक है. Then we'll put a rubber band here, as I have done it here already, right. So this I have tied with the help of a rubber band और pouch बना के हमने funnel इसके बीच में डाल दी. So this is the arrangement which I have done it here. Now you see what I am going to do here. This is starch sole, you can see. This is the starch sole, and when you add starch sole to this, we are filling this bag of butter paper with starch sole. Again, you know, sole means colloidal solution I am talking about. So we are adding colloidal solution into this. So we have added enough amount. You know, generally colloidal solutions, they have an impurity of sodium chloride. I would like to say colloidal solutions are stable when adsorbed layer is this, and this adsorbed layer comes from the electrolyte or the small impurity which is already present in the colloidal solution. If that small impurity is there, that will make a adsorbed layer around it, and that will make the sole stable. But you know, if electrolyte is present in excess, then that electrolyte will neutralize the adsorbed layer and will make it unstable, and coagulation will happen. So I am coming to the process, the activity which I am showing here. You see, when you add starch sole, intentionally I have added small amount of sodium chloride into this, which is acting here as an electrolyte, as well as it is present as an activity. Generally the starch soles which are available in the market, they have this kind of impurity. Impurity means electrolyte. यहाँ पे impurity का मतलब कुछ कंकड़ पत्थर नहीं है, इसका मतलब है यहाँ पर electrolyte present है, which is present as an impurity. If you want to purify your sole, you want to get rid of NaCl which is present in it, or then you can do the process of dialysis. Dialysis is a technique of purification of colloidal solutions. It is also a technique to coagulate. Let me tell you how it happens. Here in this case, sodium chloride is present as impurity, and we have filled this pouch or bag with starch sole, and we have suspended it into a beaker which contains distilled water. I have intentionally taken distilled water into this, and if you keep it suspended in this maybe for 15-20 minutes, then you will see that sodium chloride which is present in starch sole will diffuse out of this butter paper, and it will come in the solution. It will diffuse out. तो आपके solution में अब क्या आ जाएगा? Sodium ions और chloride ions. They will come out in the solution. मैंने distilled water क्यों लिया यहाँ पे? अगर मैं tap water लेती तो उसमें already sodium ions, sodium तो नहीं, chloride ions and other minerals were already present there. तो मैंने यहाँ distilled water लिया so that sodium ions and chloride ions, when they'll diffuse out, then I can check the presence of chloride ions easily with the help of AgNO3. For that I need to keep it for some time, maybe for 15-20 minutes, and you will see sodium and chloride ions will come out. Let's wait for some time, then I'll show you the test of chloride ions also. I have AgNO3 solution also. This is silver nitrate. We'll do the test of it after some time. You know, if you keep on doing dialysis repeatedly, आपने एक बार डायलिसिस किया, डायलिसिस मतलब आपने इसको इस डिस्टिल्ड वाटर में सस्पेंड करके रखा, सोडियम एंड क्लोराइड आयंस विल कम आउट. Then you take again some more amount of, throw this solution, दोबारा से थोड़ा और distilled water लो, फिर से suspend करो, some more amount of sodium and chloride ions will come out of it in the distilled water. If you keep on doing this, you will see all sodium ions and chloride ions will come out in the distilled water. Now no more sodium and chloride ions are there. It means वो जो starch molecules, जो starch sole के particles थे, उनके around जो adsorbed layer थी वो पूरी disturb हो गई. और अगर वो डिस्टर्ब हो जाती है, यू ऑलरेडी नो, अगर किसी भी कोलाइडल पार्टिकल के अराउंड ये एड्सॉर्ब लेयर डिस्टर्ब हो जाती है, देन व्हाट हैपन्स, दे ऑल गेट कोएगुलेटेड. तो स्टार्च सोल में भी लगातार जब बार बार सोडियम आयंस और क्लोराइड आयंस डिस्टिल्ड वाटर में आते जाएंगे, देन स्टार्च सोल विल ऑल्सो कोएगुलेट. So this process is called as dialysis. This is used for two purposes. First one, to purify the colloidal solution, and number two, to coagulate the colloidal solution. So once the impurities are removed, then this solution will coagulate. So small amount of electrolyte is required to stabilize colloidal solution because they make adsorbed layer and make it stable.
Okay, ma'am, I have a question here.
Yeah.
And also I want to remind you, we have got 15 minutes left. And dialysis, so you mentioned the purpose and how's it done. I've heard dialysis regarding the patients which
suffer from kidney problems.
Failure, yes.
She very rightly asked. So I'm sure that you also must have seen the patients like those who are suffering from kidney problems and they go to hospital for dialysis.
Yes.
You know, dialysis में इसमें क्या होता है kidney problem में patient को कि किडनी फेल हो जाती है तो किडनी का पर्पस क्या होता है, किडनी का काम क्या होता है कि वो ब्लड को प्योरीफाई करती है. ब्लड को कैसे क्या प्योरीफाई करेगी, उसमें जितने टॉक्सिन्स हैं, वेस्ट मटेरियल है और एक्सेस आयंस हैं, वाटर है एक्सेस में, उस सबको रिमूव करती है. सो समहाउ यू नो जब आपका इतना सारा सब्सटेंस किडनी सेपरेट नहीं कर पा रही है, देन यू नीड टू गो टू अ डॉक्टर. फिर वो आपको आर्टिफिशियल किडनी पे रखेंगे, आर्टिफिशियल किडनी से आपको कनेक्ट करेंगे. कैसे? आपका ब्लड डायलाइजर में जाएगा. दैट डायलाइजिंग मशीन इज देयर बिकॉज योर किडनीज आर नॉट वर्किंग. तो आपका ब्लड डायलाइजर में जाके प्योरीफाई होगा, एक्सेस waste material will be removed out and then it is coming back to your blood. So this process of dialysis is again the purification of blood. And what is blood? Blood is a colloidal solution and it is undergoing dialysis, and this is the same thing, purification of colloidal solution we are doing through this.
So here we can say that chemistry is associated with biology.
Biology, and it is everywhere. It is there for your for the benefit of mankind. So आपको healthy रखने के लिए, so you must take care of your kidneys. Just follow the healthy lifestyle so that you can be healthy for always.
Yeah.
So let's try, although it is just we have spent only very small time, we have kept it there only for small time, but let's perform this activity. Whether chloride ions have come in the solution or not, I am not sure. Otherwise we can test it later also. I have taken this water and then I will add sodium silver nitrate solution. You all know how to test the presence of chloride ions. See, if I add few drops of this, let me find out, I don't know. Oh wow, Tanvi, you can also see white colored appear, which indicates that, so chloride ions which have been diffused out, now they are reacting with AgNO3 and you got white PPT of silver chloride. So you know chemistry is colorful also.
It is super interesting.
Yeah, white is a combination of all colors. So this is through the diffusion of sodium ions and chloride ions.
Yeah. And ma'am, chemistry, for chemistry we say it's based on facts. Is it true?
Yeah, it is very logical. Tanvi really commented well. So it is very logical and it generates critical thinking among the children, teachers and all those who are associated with this.
Okay.
You know, we have some other techniques also, as I have told you. So another technique is when you add, I have one more sheet here. Yes, I'll take one more technique how this coagulation happens here. You know, I have taken a very dilute solution of potassium iodide. You know, when I add very dilute solution of AgNO3 into it, the two react together and you get AgI and KNO3. ठीक है, अब आपका AgI, KNO3 तो आपका इलेक्ट्रोलाइट है एंड AgI सिल्वर आयोडाइड के कोलाइडल पार्टिकल्स आपके बन गए. पर कोलाइडल पार्टिकल्स ऑलवेज प्रेफरेंशियली एड्सॉर्ब आयोडाइड आयंस अराउंड इट. यू नो, ये आयोडाइड आयंस जो आपके हैं ये इसको स्टेबलाइज करेंगे बिकॉज ऑल सिल्वर आयोडाइड पार्टिकल्स दे हैव एड्सॉर्ब्ड लेयर ऑफ आयोडाइड्स अराउंड इट. तो ये सारे आयोडाइड दे आर रिपेलिंग ईच अदर एंड दे रिमेन फ्लोटिंग इनटू द सॉल्यूशन. बट समहाउ इफ़ यू एडिट थोड़ा सा स्मॉल अमाउंट में, जो KNO3 है ये हमें डिस्टर्ब नहीं करेगा, पोटेशियम आयंस एंड नाइट्रेट आयंस आर प्रेजेंट इन स्मॉल अमाउंट, सो यू नो ये इस एड्सॉर्ब लेयर को डिस्टर्ब नहीं करे. बट समहाउ इफ़ यू ऐड एक्सेस ऑफ KNO3 और एनी अदर इलेक्ट्रोलाइट, देन यू हैव टू मैनी पोटेशियम आयंस एंड नाइट्रेट आयन. फिर क्या होगा बेटा, ये पोटेशियम आयंस दे विल बी अट्रैक्टेड टुवर्ड्स आयोडाइड आयन, और ये इसके पास जाके सारे आयोडाइड आयंस को न्यूट्रलाइज कर देंगे, और जब न्यूट्रलाइज हो जाएंगे तो मैंने आपको बताया था व्हाट विल हैपन, दे ऑल विल क्लब टुगेदर, दे ऑल विल प्रेसिपिटेट एंड प्रेसिपिटेशन हैपन्स. सो शैल आई से स्मॉल अमाउंट ऑफ इलेक्ट्रोलाइट is healthy for the stability of colloidal solution, but when you have excess of potassium nitrate, it is responsible for coagulation. Now the question arises, potassium ion ने तो coagulate किया, nitrate भी किसी को कर सकते हैं क्या coagulate? You know, nitrate is negatively charged को coagulate नहीं कर सकते. Why? इनके अराउंड भी negative आयन और nitrate के पास भी negative, they'll be repelled. पर nitrate किसको coagulate कर सकता है? ये उन colloidal solutions को coagulate कर सकता है which are positively charged. So I am coming to that. The next sheet is indicating that only. We have a very important rule which is Hardy-Schulze rule. I have explained it with the help of two examples. Again, I have taken my favorite ferric hydroxide. You know, ferric hydroxide is surrounded by ferric ions. So it can be coagulated with negative ions. कौन से? Ferrocyanate ion, phosphate, sulfate and chloride. So, and similarly, if I see the second example, arsenic sulfide is surrounded by sulfide ions. You know, this is negatively charged. It can be coagulated with aluminium ions, calcium ion, potassium ion, all positively charged. So, positive and ions can coagulate negatively charged colloidal solution, and negatively charged ions, they can coagulate positive ions. This is Hardy-Schulze rule, first part, which says that ions carrying charge opposite to that of the colloidal solution are responsible for coagulation. जो opposite charges होंगे वही coagulate करेंगे. अगर positive है तो उसको negative करेंगे और negative है तो positive करेंगे. तो क्या सारे इफेक्टिव हैं? ये इन आयंस को हम क्या बोलते हैं? दे आर कॉल्ड एज कोएगुलेटिंग आयंस बिकॉज दे आर रिस्पॉन्सिबल फॉर कोएगुलेशन. जब सारे कर सकते हैं तो इनमें से कोई डिफरेंस है क्या? Yes, there is a difference. In out of all these four, I will say ferrocyanate ions are most effective in carrying out the coagulation. Why? This is given by Hardy-Schulze rule, second part. Beta, it says that more the charge over the coagulating ion. I can say more the valence of the coagulating ion, more is the coagulating power. इसकी सबसे ज़्यादा coagulating power है. थोड़ा सा डालने पे भी, suppose chloride के 10 drops are able to coagulate it, सल्फेट के हो सकता है 5 ही ड्रॉप उसको कोएगुलेट कर देंगे, फॉस्फेट के हो सकता है सिर्फ 3 ड्रॉप कर देंगे, और मे बी फेरोसाइनेट आयन के 1 या 2 ड्रॉप्स आर एबल टू कोएगुलेट. सो सेकेंड रूल ऑफ हार्डी-शुल्ज, इट सेज दैट coagulating power of the ion is actually directly proportional to the charge over the ion, or you can say valence on the coagulating ion, valence on the ion. So children, I think Hardy-Schulze rule is clear to you, and this is also.
I have a doubt here, ma'am.
Yeah, Tanvi, yes, I would like to answer.
So regarding this, so can we say that do all the positively charged ions cause the coagulation of negative salts?
Yes, you are very right. Positive ions will coagulate negatively charged colloidal solution and vice versa.
Okay.
So here you can say oppositely charged ions are responsible for coagulation of a particular sol or colloidal solution, you can say parallelly.
Okay, okay, that was my doubt.
Yeah. So I would like to go for the applications of colloids and colloidal solutions, coagulation, Hardy-Schulze rule. We have beautiful applications around us. So let's talk about them. It is I have listed some of the interesting examples. I'll mention each one of them.
Sure, ma'am, we have got last 5 minutes left.
Okay. So you must have seen beta blue color of the sky. Sky is blue in color. Why is it so? You know, dust particles are there which are present in the air. They are very they act as colloidal solution. When white light falls on it, then scattering of light takes place. You know, scattering किसका स्कैटरिंग सबसे ज़्यादा होगा? ब्लू का, बिकॉज ब्लू का मिनिमम वेवलेंथ है, सो इट स्कैटर्स द maximum. So that is one of them, blue color of the sky. Then sea का blue color क्यों है बेटा? That is also based on the same fact. Then we have fog and mist. You might have seen winters में जब आप बाहर निकलते हो, आपकी साइकिल पे, आपके स्कूटर पे droplets होती हैं, they are all colloidal solution. बट स्मॉग अगर उसके साथ फॉग के साथ मिस्ट के साथ मिल जाएगी, इट बिकम स्मॉग विच इज़ वेरी हार्मफुल फॉर अस. एंड यू नो ये कहाँ से इतना स्मॉग आ रहा है? कभी कभी हमारे जितने व्हीकल्स हैं, बर्निंग ऑफ फ्यूल्स की वजह से, फार्मर्स की वजह से, दिस इज़ देयर. क्लाउड्स आर ऑल्सो कोलाइडल सोल्यूशन. एंड रेन ड्रॉपलेट्स, इसको हम प्रेसिपिटेशन बोलते हैं, दैट इज़ ऑल्सो कोलाइडल सोल्यूशन. आर्टिफिशियल रेन, यू नो समटाइम्स यू माइट हैव हर्ड कि जब 2008 में ओलंपिक्स होने थे बेटा, उस टाइम पे चाइना ने वो चाहता था कि ओपनिंग सेरेमनी जो है वो प्रेसिपिटेशन फ्री हो, उस दिन रेन ना हो. देन ही यूज दिस काइंड ऑफ टेक्निक एंड इट इज़ कॉल्ड एज क्लाउड सीडिंग. So these kind of attempts were done in New York also, China also, and even in India also. So this technique is used for this is weather modification. Then food articles are there बेटा. मिल्क के बारे में हमने बात की. हलवा आपके घर में special occasions पे बनता है. Have you noticed that this is also a kind of colloidal solution? blood is also a colloidal solution. जब भी बेटा कोई wound लगे, कोई cut हो और blood बाहर निकल रहा हो, you know उसके ऊपर alum लगा देना चाहिए, because aluminium के ऊपर charge 3+ होता है. It has the maximum coagulating power. So it is again based on Hardy-Schulze rule. Then clotting of blood is done by alum. Soils are also colloidal solution. Delta is the topic of geography, but there is chemistry behind it, because our like you know river water is actually a colloidal solution of clay. But when you mix, when it go into the river, then lots of minerals are there, so excess of electrolyte coagulated. So coagulation of river colloidal solution will give rise to formation of delta. Then we have other applications also. In industries you might have seen there are long chimneys which are there. उनको हम connect कर देते हैं precipitators के साथ. They are called as Cottrell smoke precipitator. वो भी opposite charges की तरह जब smoke इनके through pass होके जाता है तो वो opposite terminal की तरह attract हो जाते हैं और precipitate हो जाते हैं based on the coagulation technique. और जो बाहर air निकलती है that is free of pollutants. You know drinking water में भी अगर हम alum डाल देते हैं तो aluminium ions they coagulate the suspended impurities. सीवेज की कितनी ज़्यादा प्रॉब्लम है बेटा हमारे पास. सीवेज को भी हम कैसे कोएगुलेट कर सकते हैं, दैट इज़ ऑल्सो बेस्ड ऑन कोएगुलेशन एंड केमिस्ट्री इज़ प्लेइंग एन इम्पॉर्टेंट रोल इन दिस. आई लोशंस विच इज़ आर्जीरॉल एंड अदर मिल्क ऑफ मैग्नीशिया, जब एसिडिटी हो जाती है दैट इज़ ऑल्सो अ कोलाइडल सोल्यूशन. बेटा आज यू मस्ट बी नोइंग दैट लेदर बैग्स जो हम यूज़ करते हैं दे आर मेड अप ऑफ एनिमल हाइड्स. एनिमल की स्किन से बनते हैं. इसके लिए बहुत सारे लोग उनको मार भी देते हैं, क्योंकि उसको जब एनिमल हाइड को हम नेगेटिवली चार्ज टैनिन में डिप करते हैं तो वो लेदर हार्ड हो जाता है और उससे फिर हमारे बहुत सारे लेदर प्रोडक्ट्स बनते हैं. सो यू मस्ट बी नोइंग बहुत सारे एनिमल लवर्स दे डोंट वांट टू यूज़ लेदर बैग्स. देन cleansing action of soap and detergent is very interesting. It happens in 2 steps, micelle formation and emulsification. Rubber industry में latex is also a colloidal solution. Paints, inks, synthetic, and these all are the chemicals which are used in this colloidal. And so today we have seen the applications of colloids, and they are present all around us. Then we saw coagulation, how it happens, what are different techniques, and Hardy-Schulze rule, which is very important. And there are various applications which were there.
Okay.
So
thank you so much, ma'am, for explaining these topics, these processes. And one of our viewers, he joined later, and they were asking about soul and coagulation. So I would request you to watch the entire session from the beginning for this understanding, and you'll understand it properly, because ma'am explained it in such a manner that it is for everybody, for you, for me, and for all of you all, whosoever is watching this session. Thank you so much, ma'am, for being here, for your time.
Ma'am, I would like to say chemistry is everywhere. Even chemistry is present between us also. We share good chemistry.
True.
So it is between the student and teacher, between you and me, between me and my viewers. So I am thankful to all of you. Thank you very much.
Thank you once again, ma'am. Thank you to all the students for asking those questions. Ma'am tried to answer all your questions, and we hope that you got satisfying answers. Keep on watching these sessions and these topics, these subjects we bring only for you. We'll come back again on Monday at 2 o'clock for more sessions. Keep on watching our YouTube channel NCERT Official, and keep your questions ready as well. Till then, take great care of yourself. Be healthy, be happy. Namaste.